Far beyond the familiar worlds of the inner solar system, where Earth, Mars, and Jupiter reside, lies a hidden and largely unexplored frontier. It's a region of space so distant that it feels almost beyond reach, an icy expanse where the sun is but a feint in the sky. This is the Kuiper Belt, a sprawling and mysterious region that starts beyond Neptune and extends out for billions of miles, far beyond the orbits of the major planets. But despite its seeming isolation, the Kuiper Belt is anything but empty. It holds some of the solar system's oldest and most primitive objects, frozen remnants from the very dawn of our solar system. Here, among icy comets and dwarf planets, lie some of the most exciting and perplexing mysteries waiting to be unlocked. What can these distant objects tell us about our origins? And what secrets might they hold about the birth of planetary systems, not just in our own backyard, but across the galaxy? The Kuiper Belt lies between 30 and 50 astronomical units from the Sun. An astronomical unit, or AU, is the distance from the Earth to the Sun, about 93 million miles. At the closest point, this makes the Kuiper Belt roughly 3 times farther from the Sun than Earth. And at its farthest point, it extends beyond the reach of Neptune, the most distant planet in our solar system. Unlike the relatively well-known regions closer to the Sun, the Kuiper Belt is a shadowy, distant wilderness. Yet, its importance to our understanding of the solar system cannot be overstated. It's a place where remnants of the solar system's formative years, more than 4.5 billion years ago, have been preserved in frozen isolation. These ancient objects are the building blocks that never quite coalesced into planets. Instead, they stayed scattered across this cold region, preserving their secrets in a frozen state. The Kuiper Belt is home to a dizzying variety of objects. Some of these are large enough to be classified as dwarf planets, like Pluto, Haumea, and Makemake. These small worlds may not be planets by modern definition, but they are key players in our understanding of the solar system's outer regions. These objects, along with countless other icy bodies, are thought to have formed at the same time as the planets but never grew large enough to achieve planetary status. But it's not just the dwarf planets that captivate us. The Kuiper Belt is also teeming with comets, icy wanderers that often travel vast distances across the solar system. Some of these comets are like frozen time capsules, holding materials unchanged since the birth of the solar system. When they venture closer to the Sun, they heat up and release gases, forming the familiar glowing coma and long, spectacular tails we see from Earth. But even more intriguing is the fact that the composition of these comets may provide us with the building blocks of life itself: organic molecules, water, and other substances essential for life as we know it. Scientists have long regarded the Kuiper Belt as the fossil record of our solar system's early days. Objects in this region are incredibly old, perhaps as old as the solar system itself. By studying them, we gain crucial insights into the conditions that existed in the early solar system, offering clues to how the planets formed, how moons came to be, and how even the conditions necessary for life might have emerged. These objects, largely unchanged over billions of years, are like untouched archaeological artifacts, waiting for us to unlock their secrets. They hold answers to questions such as: how did the Sun's planets and moons take shape? Why did some objects in the outer solar system remain small and icy, while others grew into massive planets? And, perhaps most fascinating of all, could these objects hold clues to the existence of life beyond Earth? To understand the Kuiper Belt, we must first look back to the birth of the solar system. About 4.5 billion years ago, The sun and its planets began to form from a vast cloud of gas and dust. The material closer to the sun came together to form the rocky planets, Mercury, Venus, Earth, and Mars, while the colder, more distant regions gave rise to the gas giants, Jupiter, Saturn, Uranus, and Neptune. Beyond Neptune, in the outer reaches of the solar system, the material that could not form planets settled into the Kuiper belt, a vast, icy region of leftover building blocks. But why didn't these objects become planets? The answer lies in the gravitational influence of the giant planets, especially Jupiter, which prevented many of these bodies from coalescing. Instead, they remained frozen in the Kuiper belt, locked in place, preserving the ancient conditions that existed when our solar system was born. One of the most groundbreaking missions to explore this distant frontier was NASA's New Horizons. Launched in 2006, New Horizons traveled for nearly a decade, covering more than 3 billion miles before reaching Pluto in 2015. For the first time, we got an up-close look at this mysterious dwarf planet and its icy world. But New Horizons didn't stop there. After its historic flyby of Pluto, it continued its journey deeper into the Kuiper belt, heading toward even more distant and unexplored objects. What it found out there could revolutionize our understanding of the outer solar system. New Horizons' mission didn't end with Pluto. In 2019, the spacecraft passed by an object known as Arrokoth, an icy, reddish body located over 4 billion miles from the sun. Arrokoth, shaped like a snowman, was revealed to be two smaller bodies that gently collided and stuck together billions of years ago. This discovery gave scientists a rare opportunity to study an object from the early solar system that had never been altered by the gravitational forces that shaped the larger planets. Arrokoth provided us with a snapshot of the solar system's early days, showing us how the building blocks of planets might have come together. These types of discoveries are invaluable in helping us understand the processes that created the worlds around us, and even the potential for creating life on other worlds. The data from New Horizons is helping scientists piece together the puzzle of the solar system's formation. Objects like Arrokoth are crucial because they haven't experienced the same violent collisions and interactions that other objects in the solar system have. They remain, in many ways, fossils from the early solar system, a record of the conditions that existed billions of years ago. From these ancient objects, scientists are learning not only about how our solar system formed, but also how planetary systems may form around distant stars. These discoveries are reshaping our understanding of how solar systems evolve, and they could help us answer one of the most profound questions of all. Are we alone in the universe? Comets are another critical piece of the Kuiper belt puzzle. These icy visitors from the outer solar system are more than just beautiful celestial phenomena. They are ancient carriers of information, holding clues to the chemical composition of the early solar system. As comets travel from the Kuiper belt toward the sun, they release gas and dust, forming spectacular tails that light up the night sky. But what's even more fascinating is what these comets are made of. Comets contain a mixture of water, organic molecules, and other chemicals that could have been present in the early solar system. Some scientists even believe that comets could have played a role in delivering the water and organic compounds necessary for life to Earth. By studying these comets, scientists hope to uncover how life on Earth might have begun. Could these frozen objects from the Kuiper belt have been the first carriers of the ingredients for life, water, and organic molecules across the solar system? If so, could other planets, moons, or even exoplanets harbor similar icy wanderers that brought life to distant worlds? These questions remain unanswered, But each new discovery brings us one step closer to understanding the origins of life itself.